So in this case, the shape is called trigonal planar. Trigonal planar, and the bond angles are 120 degrees. Now in a plane, the bond angle is always 120 degrees, so this makes a lot of sense. Trigonal planar, bond angles 120 degrees. An example of this will be AlCl3. You remember AlCl3? The molecule AlCl3. So that's an example of trigonal planar. You have to remember the name of the shape, and you have to remember the bond angles. Okay, so very important, name of the shape and bond angles. Then if it's two, in this case the steric number is still 3, but this time it's 2 bond pairs, 1 lone pair. So in this case the shape is called bent or angular. I always go with bent, and the bond angle is less than 120 degrees. Like you can write 120 degrees, not a problem at all. Okay. Then when the steric number is 4, it's said to be tetrahedral. When the steric number is 4, and out of these 4 there are 4 bond pairs and 0 lone pairs, then in that case the molecule is said to be tetrahedral. So an example of this molecule is Ch4 methane. Methane is tetrahedral. We will look at this in the slides to come. But Ch4 tetrahedral, you can see 109 degrees. Now these wedges and dashes is something we will talk about soon, but don't worry, we will talk about them. They're actually a way of representing 3D geometry. Okay, so 109 degrees tetrahedral, remember. So actually it's not 109, it's 109.5, and our A levels, they want to know 109, they want you to write 109.5 degrees, not 109 degrees. So yeah, go with 109.5 degrees. Okay. Now then we have trigonal pyramid. Now this is out of a steric number of 4, there are 3 bond pairs, there's 1 lone pair. In this case it's called trigonal pyramid. The bond angle is 107 degrees. Each bond angle is 107 degrees. And an example of this molecule will be NH3, ammonia. So ammonia has 3 bond pairs between nitrogen and hydrogen and 1 lone pair. Yeah, so 107 degrees, trigonal pyramid. So you can also write trigonal pyramidal. It's actually another way. So again, A levels want you to, in A levels they want you to write trigonal pyramidal, not pyramid but pyramidal. Okay, just add the AL in the end. Then we have 2 bond pairs, 2 lone pairs. So this was what we had with water. 2 bond pairs, 2 lone pairs. In this case, the bond angle was 104.5 degree, if you remember. Yeah, and the example of this was water, H2O. Then we have trigonal bipyramid, which is we have 5 bond pairs, 0 lone pairs. Now trigonal bipyramid, there are actually 2 types of bond angles here. So this can be a little tricky. So first I'll give you an example of this molecule. It is PCl5. PCl5, a very important molecule because you'll be using this for many of your reactions in organic chemistry in both AS levels and A2s. So it's a very important reactant. Now if you see the 2 X's which I've marked over here, they're actually perpendicular to the plane. And what I mean by perpendicular to the plane is that one is actually above E, one is actually below E. Okay, and the other 3 X's, they are in the same plane and they are perpendicular to this X. So you can see 90 degrees. 90 degrees, that's why, because they are perpendicular, but to each other they are in the same plane. And if you look at trigonal planar, same plane. So actually what you should look at trigonal bipyramid is, you should look at a linear vertical, and the rest of the molecule as trigonal planar. So this is actually trigonal bipyramid. So first you look at a linear vertical, and then you look at and then you have trigonal pyramidal. Trigonal planar. So there are 2 bond angles. Between the vertical X and the planar X, it is 90 degrees. And between the planar X's, it is 120 degrees. So there are 2 bond angles. You must remember this. Then we have 6 bond pairs and 0 lone pairs. This becomes even more interesting now. 6 bond pairs, 0 lone pairs.